Hi everyone. Today we are going to do trigonometry lesson 5. It is solving two triangle problems, part 1. As usual, I will call mine answer key. Okay. And so here's the warm-up. Remember, we have 3 tools of trigonometry to solve right-angled triangles. Number 1 is the Pythagorean theorem. And that is c squared equals a squared plus b squared. We have SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And we also have angle sum of triangle equals 180 degrees. Now that's true in any triangle, that angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay, and remember that the Pythagorean theorem and SOHCAHTOA are just for right-angled triangles. So triangles that have that little 90-degree box in them, like that. Okay, so today we'll use these tools in order to solve 2 and 3 triangle problems. Whenever you solve these problems, you must first identify the right triangles. Okay, the ones with 90-degree angles in them. This is because these are the only triangles we know how to solve so far. There are 3 main types of 2 triangle problems. The first one is an addition type, and it asks you to find the side AC. So AC is that whole side right there. The 3 triangles are triangle CDB, triangle ADB, and then the whole big triangle, which we could call triangle ACB. To find AC, you must, let's cross off the word find there, you must use the right-angled triangles. These are triangle CDB and triangle ADB. And so what you do is you find the length from A to D. So you find this little length, let's call it x, and you find the length CD, which is this one, and we can call that y, and then you add them to find AC. So that's why this is called an addition problem. Okay, you're finding 2 sides and adding them together. Make sure you label the different pieces you are trying to solve for. Okay, so let's figure out x and then y, and then we add them together to find the side AC. Okay, so if this is the angle we have in the triangle, remember straight across from it is the opposite side, so x is the opposite. And across from the 90 is the hypotenuse. We don't know that side, but we know the side that is beside the 31-degree angle, that must be the adjacent. Okay, so we have the adjacent and we're looking for the opposite. And if we write down SOHCAHTOA, which trig ratio deals with opposite and adjacent? That's tan. So I would go tan of 31 degrees is equal to the opposite, which is x, divided by the adjacent, which is 14, and solve that for x. Okay, and remember the way to solve this, since x is being divided by 14, we would simply multiply both sides by 14. That cancels, so now x is by itself. X is equal to 14 times tan 31. Let's get out our virtual TI. Our angle is in degrees, so make sure your calculator is in degree mode, and notice that the degree is highlighted. Good, so I'm just going to go 14 tan 31, bang, 8.4. And the 14 was in centimeters, so this is centimeters. So there's x. Now let's look in the upper triangle. We have this 52-degree angle. Across from it is the opposite. Across from the 90 is the hypotenuse. So again, this 14 is the adjacent, and we're looking for that opposite side. Okay, opposite and adjacent again, so that's tan. So I would go tan of 52 degrees is equal to the opposite is y, and the adjacent is 14. And then multiply both sides by 14 to get y by itself. Okay, so y is 14 tan 52. Which is 17.9 centimeters. All right, so we found x and y, and we can finally say, therefore, the side AC is equal to x plus y. It's made up of those two sides. So we would add those together. 8.1 centimeters plus 17.9 centimeters, and we get that AC is equal to let me just do a quick double check. Sorry, 14 tan 31 is 8.4. So this little guy here is 8.4. And if we go 8.4 plus 17.9, we get AC is 26.3. Okay, and so that is an example of an addition type question. Number 2 is subtraction, and it says find the side BC. So it wants us to find that little side right there. The three triangles are triangle ABD, triangle ACD, the big one, and then triangle BCD. To find BC, you must use the right-angled triangles. These are triangle ABD with a 32-degree angle, and the big right triangle, angle ACD, with this whole angle here, which is 32 plus 21, 53-degree angle. Okay, so you find A all the way to C first of all. So our plan of attack is you find this whole length and you find AB, then subtract them to find BC. Okay, so we find that whole big length first in the big 90-degree triangle, and then we find AB, A to B, in the little 90-degree triangle. And if I were to do this big line here minus the smaller one, it would leave me this piece from B to C. Make sure you label the different pieces you were trying to solve for. Okay. So the first thing I'm going to do, guys, is I'm going to work in the big 90-degree triangle. Okay, and so this whole angle here is 53 degrees. We want to find this whole side. Let's call it X. And it is right across from the 53-degree angle, so this is the opposite. Across from the 90 is the hypotenuse, so this is the adjacent. Okay, so we're looking for the opposite. We have the adjacent, so that's tan again. So I would go tan of the whole angle, which is 53 degrees, is equal to the opposite side is x, the adjacent is 12. And since x is being divided by 12, do that simple process of multiplying both sides by 12. And we get x equals 12 tan 53, which is 15.9, and that's going to be millimeters. And that's what we have for x. So now I'm going to erase all of this. So we just found that from C down to A, that is 15.9 millimeters. Okay. Now we need to figure out this side right here, which I will call Y. So we're going to use the little 90-degree triangle. We're going to use the 32-degree angle. Across from the angle is the opposite. Across from the 90 is the hypotenuse. So this side must be adjacent. Okay, so we have adjacent again, and we're looking for the opposite. Which one deals with opposite and adjacent? That would be tan, right? If you do SOHCAHTOA. SOHCAHTOA, opposite and adjacent comes from tan. So I would say tan of 32 degrees is equal to y over 12. And since y is being divided by 12, multiply both sides by 12, and you get y equals 12 tan 32. 12 tan 32. Bang. 7.5. So there's y. We just figured out that that is 7.5 millimeters. So now perhaps I can erase some of the stuff on my diagram. So we just found that from A to B, that is 7.5 millimeters. Okay, and so hopefully you can see, guys, that if we subtract 7.5 from the 15.9, it will leave us that BC that they want us to find. So we can say, therefore, BC is equal to, we called this length x, by the way, and this one y, so it will be x minus y. (15.9 millimeters minus 7.5 millimeters). And so BC is equal to 15.9 minus 7.5, 8.4. Okay, and so that is an example of a subtraction question. Okay, the third type of two-triangle problem is called a stepping stones question. They want us to find the side AB. Okay, so they want us to find from here all the way to here. Maybe we could call that Y. The two triangles are triangle ADC and triangle ABC. And to find AB, you must have an angle and a side. However, you only have an angle at the moment. We just know that angle, and of course the 90 here. You have to have an angle and a side to be able to use trig to get another side. So what we're going to do is we are going to use triangle ADC. So we're going to use this triangle first to find the side AC. So to find this side, and then once we have that X, we can use it to get Y. So that's why it's called a stepping stone. We kind of work in this triangle here. First we get X, and then we move from that step to working in here to then getting Y. Okay, so that's the plan of attack. So we're going to start in this triangle. And we need to get this side X so that we can use that to get Y up here. Okay, so in this first red triangle, there's the angle that we have. Straight across would be the opposite side. Across from the 90 is the hypotenuse. So that's the hypotenuse, and so this must be the adjacent. So this time we are working with adjacent and hypotenuse. So if I write SOHCAHTOA again, there's adjacent, there's hypotenuse. We are talking about cos. So I would go cos of 31 degrees is equal to adjacent divided by hypotenuse. So 17 over x. And remember, when the x is on the bottom, these end up switching spots when you do the algebra. So x is equal to 17 over cos 31. And 17 divided by cos 31 is 19.8. And that is going to be millimeters. Okay, so we've now figured out that this is 19.8 millimeters. And now what we're going to do is switch to working in this green triangle. See, that's a 90-degree angle. Okay, we're going to work in here to get y. So there's the angle that we have straight across from the angle. This side is the opposite. Across from the 90 is the hypotenuse. So we have the opposite side and the hypotenuse. Which one deals with opposite and hypotenuse? That would be sine. So I would go sine 68 degrees equals 19.8. Opposite divided by the hypotenuse is y. And these guys switch to solve for y. So you get 19.8 divided by sine of 68 degrees, and that gives us 21.4. millimeters. Okay, and that is y, and y goes from A to B, so this is equal to AB, which is what they wanted us to find at the beginning. All right, and we'll finally finish off with example 4. This time it wants us to find an angle MNO. So if I move from M to N to O, it wants us to find this whole big angle right here. Okay, and that big angle is made up of two little angles, this one here and this one. So, as you probably could guess, we have to find the two little angles separately and then add them together. So we need to find this angle, let's call it alpha, and we need to find this angle, let's call it beta, and then we'll add alpha and beta together. So in the first 90-degree triangle, see how we've got 90 right here, alpha is there, so the 11 is the opposite side, across from the 90 is the hypotenuse, and so this side is adjacent. Okay, so we're going to be working with opposite and adjacent. Opposite and adjacent. That comes from tan. So tan of alpha is equal to, the opposite is 11, adjacent is 18. And remember, to get an angle, you have to go tan inverse of 11 over 18. So I'm going to go shift tan, 11 over 18, bang. 31 degrees, let's say. And in this second triangle here, we have angle beta. Across from beta is the opposite, which we don't know. Across from the 90 is the hypotenuse. So that means that the 18 must be the adjacent side. So I circled adjacent and hypotenuse. Adjacent and hypotenuse comes from cos. So I would go cos of beta is equal to The adjacent is 18 and the hypotenuse is 22. So beta is equal to cos inverse of 18 over 22. So I would go shift cos 18 over 22, bang, about 35 degrees. Good, so again, angle MNO, if I go from M to N to O, see how it's made up of alpha and beta, so we would say angle MNO is equal to alpha plus beta, which is 31 degrees plus 35 degrees, which is 66 degrees. Alright, so there you go, everyone. That is lesson 5 for trigonometry. Here's the assignment as usual. So give those a try. There is an answer key at the end right here. And as usual, I will do a video of homework solutions and send them to you later this week. Okay, everybody, take care, and I will talk to you soon.